The cold bit deep into the bones of anyone unfortunate enough to be in Berlin during January 1945. The city was dying, slowly strangled by Allied bombing and the inexorable approach of Soviet forces from the east. But in a frozen warehouse on the outskirts of the capital, removed from the immediate chaos of war, Dr. Henrik Becker was about to make a discovery that would crystallize everything wrong with Germany's strategic position in a way that no amount of military briefings ever could. Becker was the chief engineer at Heeresversuchsanstalt Kummersdorf, Germany's primary weapons testing and evaluation facility. At 43 years old, he had spent his entire professional life around military technology. He had examined captured Soviet tanks, analyzed Allied aircraft fragments, and tested countless German prototype weapons. He thought he had seen everything warfare had to offer. He was wrong. On his examination table lay 3 American artillery shells. They were 105mm high-explosive rounds, standard issue for American field artillery. They had been recovered from the snow-covered battlefields near Bastogne, Belgium, where American and German forces were locked in the desperate fighting of what would become known as the Battle of the Bulge. The shells looked ordinary enough from the outside, battered, dirty, scarred from their journey through gun barrels and their impact with frozen Belgian soil. But these particular shells had been found unexploded, and the reports that accompanied them were deeply disturbing. Frontline commanders were describing a new American weapon, something that seemed to violate the basic rules of artillery warfare. Shells that detonated in mid-air with perfect precision, raining shrapnel down from above. Shells that made foxholes and trenches useless. Shells that seemed to know exactly when to explode, as if they possessed some kind of intelligence. The reports seemed impossible, and Becker's first instinct had been to dismiss them as battlefield exaggeration, the kind of fearful embellishment that terrified soldiers sometimes created to explain their defeats. But the reports kept coming, from too many different units, with too much consistency. Experienced officers, men who had fought on the Eastern Front and survived the brutal grinding warfare against the Soviets, were filing reports about American artillery that defied explanation. Airburst artillery was not new. Gunners had been setting timed fuses to detonate shells above the ground for decades. But getting it right required precise calculations based on distance to target, altitude, weather conditions, wind speed, and a dozen other variables. Even experienced gun crews struggled to achieve consistent air bursts. Getting it right in the middle of a blizzard, with poor visibility and chaotic battlefield conditions, was nearly impossible. Yet the Americans were apparently doing exactly that. Not occasionally through lucky timing, but consistently, systematically, with every single shell. It was as if the shells themselves were deciding when to explode. Becker had been summoned from his regular duties to find out how. His orders came directly from Oberkommando der Wehrmacht, the German High Command. Find out what the Americans are doing. Determine if it can be countered. Assess whether Germany can replicate it. Standard questions for captured enemy equipment. But as Becker prepared to disassemble the first shell, handling it with the careful respect that unexploded ordnance demanded, he had no idea that what he was about to discover would be more than just an explanation for a tactical problem. It would be a revelation about the true nature of the war Germany was losing. Not a war of soldiers and tactics, not even a war of superior weapons, but a war of scientific capability and industrial capacity operating on a scale that defied comprehension. Becker worked methodically, as he always did. Every step was photographed, documented, measured. His hands were steady, despite his awareness that even a supposedly inert shell could kill him if he made a mistake. One wrong tool, one accidental trigger of a backup detonator, and he would be scattered across the warehouse in pieces too small to identify. The thought was always there, a low hum of anxiety in the back of his mind, but years of experience had taught him to work through it. Fear was just another condition of the work, like the cold or the poor lighting. When he finally removed the outer casing of the fuse assembly exposing the internal mechanism, Becker stopped. For a long moment that stretched into minutes, he simply stared. His assistant, Hermann Franzweber, an electrical engineer who had worked for the German telecommunications company Telefunken before the war, noticed his chief had gone completely still and moved closer to look over his shoulder. Inside the nose of the shell, nested in a space no larger than a man's fist, was a device unlike anything either engineer had ever seen. At first glance, it looked like a miniature radio set, which was impossible for reasons that were immediately obvious to anyone with even basic knowledge of radio technology and artillery. Radios were delicate instruments full of fragile vacuum tubes and sensitive components. They required careful handling and controlled environments. The idea of putting one inside an artillery shell, which would experience forces of 20,000 times normal gravity when fired from a gun, was absurd. The acceleration alone would shatter every vacuum tube, crush every delicate component, render the entire device into expensive scrap before the shell even left the gun barrel. "Franz," Becker said quietly, his voice oddly strained. "Come look at this. Tell me what you see." Franzweber leaned over the table, his eyes widening as he took in the compact assembly of components. That's a radio transmitter and a receiver, and what looks like an amplifier circuit. Her doctor, this can't be right. These components shouldn't survive being fired from a gun. The acceleration forces would destroy everything. Becker nodded slowly, his mind already racing through the implications. But they did survive. The shell was fired. The rifling marks on the casing prove it traveled down a gun barrel. It was fired, it flew through the air, and somehow, impossibly, this radio equipment survived the launch and remained functional long enough to do its job. Over the next several hours, as the weak winter sun tracked across the frosted windows of the warehouse, Becker and his team carefully documented every component of the American fuse. There was a miniature vacuum tube, far smaller than anything in German production, and designed with a robustness that seemed to contradict the known limitations of the technology. There was a battery system with an ingenious activation mechanism that Becker immediately recognized as brilliant engineering. There was an antenna that deployed after the shell was fired, unfolding in flight like a metal flower. There was a trigger circuit connected directly to the main explosive charge, and binding it all together was a level of miniaturization and integration that spoke to manufacturing capabilities that Germany simply did not possess. As they mapped out the system, meticulously tracing each connection and measuring each component, the function of the device became clear. This was a proximity fuse, a radar-equipped trigger mechanism that made the shell itself intelligent. The transmitter sent out radio waves continuously as the shell flew toward its target. When the shell approached the ground, or any large object, the reflected radio waves would change in character. Their frequency shifted by the Doppler effect. The receiver would detect this change, and when it reached a specific threshold, indicating the shell was at the optimal altitude for maximum fragmentation effect, the trigger circuit would fire the main charge. The shell would detonate without any timer, without any calculation by the gun crew, without any possibility of error. The shell itself decided when to explode. The elegance of the design was stunning. Any engineer could appreciate the sophisticated simplicity of it. But as an engineer who had spent years working with German military technology, who understood intimately what German factories could and could not produce, Becker immediately grasped the terrifying implications. This was not just a clever weapon. This was evidence of an industrial and scientific capability that operated on an entirely different level than anything Germany possessed. Becker sat at his desk in the warehouse's makeshift office area, staring at the component analysis his team had compiled. Every part of the American fuse represented a significant engineering achievement. The vacuum tubes had to be miniaturized beyond what German factories could produce. They had to be ruggedized to survive acceleration forces that would crush standard radio tubes like eggshells. The battery system used a glass vial filled with electrolyte that would shatter during firing, mixing the chemicals and activating the power source only when needed. This meant the batteries could be stored indefinitely without degradation, only becoming active at the moment of firing. German engineers had theorized about such systems, had sketched designs and done calculations. But implementing it required precision glasswork, carefully formulated chemicals, and quality control standards that German factories, increasingly bombed and operating with forced labor, could no longer maintain. The antenna system was its own marvel. It had to deploy in the milliseconds after leaving the gun barrel, had to withstand the tremendous forces of acceleration and the supersonic airflow, had to maintain its shape and conductivity while the shells spun at thousands of revolutions per minute. The Americans had solved problems that German engineers were still struggling with in experimental rockets that flew at much lower speeds under much less stressful conditions. Becker called a meeting with his senior staff. Around the scarred wooden table in the cold warehouse sat some of Germany's most experienced weapons engineers, men who had designed tanks and aircraft and submarines, men who understood intimately what was possible and what was not. Becker laid out his findings with the clinical precision of a surgeon describing a fatal disease. Gentlemen, we are looking at a functional miniature radar set designed to survive being fired from an artillery piece. The Americans have solved problems we've been struggling with for years. The question before us is simple. Can we replicate this? The discussion that followed was sobering in its unanimity. Every engineer present could see the brilliance of the American design. Every engineer also understood, with the certainty that came from years of experience with German industry, that Germany couldn't build it. Dr. Wilhelm Schaefer, who specialized in electronics and had worked on early radar development, shook his head with something approaching despair in his eyes. The miniaturization alone is beyond our current capabilities. Our vacuum tubes are too large, too fragile. To create tubes this small while maintaining functionality and durability would require manufacturing capabilities we simply don't have. It's not a matter of design. We could design something similar. It's a matter of production. We cannot produce these components in the quantities required. Not with our current factories, not with our current workforce. Another engineer, a younger man named Klaus, who had joined the facility from the Siemens Electronics division, pointed to the materials analysis that had been conducted on the components. The casings are made of high-grade aluminum alloys. The circuitry uses copper that shows no signs of the impurities we're seeing in our own materials. Every component is built to specifications we can no longer meet consistently. We're substituting materials, simplifying designs, cutting corners to maintain production numbers. The Americans appear to be building to peacetime quality standards, even in the middle of a global war. Becker made careful notes, his engineer's mind already moving ahead to the next logical question. How many of these do you think the Americans have produced? The room fell into an uncomfortable silence. These were men who had spent years calculating production capacities, estimating manufacturing timelines, assessing industrial capabilities. They knew how difficult it was to mass-produce complex electronics. They knew the bottlenecks, the material constraints, the skilled labor requirements. Finally, Hermann Franz Weber spoke, his voice quiet but certain. Based on the reports from the Ardennes, thousands, possibly tens of thousands. They're using them as standard ammunition across entire artillery. Batteries. Every gun, every battery, firing shells with these fuses as if they were ordinary ammunition. Becker did a rapid mental calculation, his pencil scratching numbers on paper as the other engineers watched. Each fuse required dozens of precision components. Miniature vacuum tubes that had to be manufactured to specifications Germany couldn't match. Resistors, capacitors, and transformers all sized to fit in a space smaller than a coffee can. Glass battery vials that had to be precisely calibrated to break at a specific force threshold. Antenna assemblies that had to deploy reliably under extreme conditions. And every component had to work perfectly, because a single failure would render the entire shell useless, wasting the explosive charge and the artillery shell itself. If the Americans were producing these by the tens of thousands, as the battlefield reports suggested, then their electronics manufacturing capacity alone was staggering. But this was just artillery fuses. The Americans were also producing radar sets, radio equipment, fire control computers, and all the other electronic systems that modern warfare required. The scale of their electronics industry had to be enormous. "Gentlemen," Becker said quietly, his voice carrying the weight of a man delivering a terminal diagnosis, "we need to understand what this means. The Americans haven't just developed a new weapon. They've developed a production system capable of mass-producing complex electronics under wartime conditions. While we're struggling to manufacture basic ammunition without shortages, they're turning out miniature radar sets by the thousands." One of the older engineers present, a man named Ernst, who had worked in German armaments since before World War I, spoke up. He had survived the industrial mobilization of the previous war, had seen German factories retooled for maximum production, understood what was possible and what was not. "Herr Doctor, with respect, I think you're underestimating the scale. If they can mass-produce something this complex, something this sophisticated, their industrial capacity exceeds anything we've imagined. This isn't just about one type of ammunition. This is evidence of an industrial system that operates on a completely different scale than ours." Becker knew the old engineer was right, and that realization led him to request something unusual from his contacts in German intelligence. He wanted access to broader intelligence data on American production. Not just tactical reports from the battlefield, but strategic assessments of American industrial capacity. He needed to understand the full picture, not just this one piece of evidence. 3 days later, sitting in a secure room with classified documents spread before him on a metal table, Becker read intelligence reports that confirmed his worst fears and exceeded them in ways he hadn't imagined possible. The American Proximity Fuse program, codenamed VT for Variable Time to conceal its true function, had been massive. Intelligence suggested it was one of the largest wartime research projects, comparable in funding and personnel to the atomic bomb program that fragmentary reports suggested the Americans were pursuing. The development had taken place at Johns Hopkins University's Applied Physics Laboratory, involving hundreds of scientists and engineers working in conditions of strict secrecy that rivaled anything in the German weapons program. But it was the production numbers that made Becker feel physically sick, a knot of dread forming in his stomach as he processed what he was reading. By late 1944, American factories were producing approximately 40,000 proximity fuses per day. Per day. That was more sophisticated electronic devices than Germany's entire electronics industry could produce in a month. And these weren't simple devices like flashlights or field telephones. Each one was a miniature marvel of engineering, more complex than most radios, incorporating technologies that Germany was still struggling to perfect in laboratory conditions. The fuses were being manufactured at multiple facilities across the United States. Western Electric, a telephone company, had converted production lines to manufacture them. So had other electronics companies, firms that had been making consumer radios and telephone equipment before the war. The Americans had taken their peacetime industrial base, their experience with mass production of consumer electronics, and weaponized it. They had applied assembly line techniques perfected by Henry Ford for automobiles to the production of sophisticated electronic warfare devices. The result was an industrial system that could produce complex weapons at a rate that seemed impossible to anyone familiar with German production realities. Becker pulled out German production figures for comparison, numbers he had reviewed countless times in his work, evaluating weapons programs. In 1944, Germany had produced approximately 40,000 aircraft total. The Americans were producing more proximity fuses than that every single day. And these were just artillery fuses, a small component of America's overall war production. The intelligence reports contained other data that painted an even bleaker picture. The Americans had first deployed these fuses in anti-aircraft roles in 1943, using them with devastating effect against Japanese aircraft in the Pacific and later against German V-1 flying bombs attacking London. The effectiveness was staggering. Traditional anti-aircraft fire might require 2,000 rounds to shoot down one aircraft. With the proximity fuse, it took fewer than 200 rounds. The fuses had been kept secret from ground combat applications specifically to prevent Germany from capturing and reverse engineering them. The fact that they had finally been deployed during the Battle of the Bulge meant one of two things, and Becker wasn't sure which possibility was more frightening. Either the Americans were so desperate, facing unexpected German success, that they were willing to risk compromising their secret weapon, or they were so confident in their industrial advantage that compromise no longer mattered. If the Germans captured the fuses, reverse engineered them, even produced working copies, it wouldn't change the outcome because the Americans could simply produce fuses faster than Germany could field countermeasures. Becker suspected it was the latter, and that suspicion was confirmed by another document, a British intelligence assessment of American industrial capacity that had been captured from a downed RAF courier aircraft. The assessment was clinical in its analysis, brutal in its conclusions. The United States was producing more war material than all other nations combined. Not just more than Germany, Britain, the Soviet Union, Japan, and Italy combined. The scale was so vast it seemed to exist in some other category of industrial activity, beyond what historical precedent suggested was possible. One statistic stood out to Becker, burning itself into his memory with the permanence of trauma. In 1944, American industry produced over 96,000 aircraft. Germany, with all its vaunted engineering expertise and technical sophistication, produced about 40,000. The ratio was more than 2 to 1, but that ratio understated the true disparity because American aircraft were on average larger and more complex. A single B-17 Flying Fortress bomber required more aluminum, more man-hours, more sophisticated manufacturing than 3 German Bf-109 fighters. The Americans were building thousands of B-17s, thousands of B-24s, thousands of transport aircraft, thousands of fighters. The material disparity was so vast it rendered tactical and operational skill almost irrelevant. Germany could win every tactical engagement, could demonstrate superior battlefield prowess in every battle, and still lose the war through simple attrition. The Americans could afford to trade material for casualties at rates that would bankrupt any other nation's war economy. Becker realized, with the cold clarity that only mathematics can provide, that he was looking at the proof of Germany's defeat. The proximity fuse wasn't just a weapon. It was evidence of an industrial system operating at a level Germany couldn't approach, let alone match. It was a glimpse into the vast machinery of American production, a system so large that this sophisticated device, this miniature radar set, was just one small component of an overwhelming whole. He spent a week compiling his findings into a comprehensive report, working late into the frozen nights, sustained by weak coffee and the grim determination of a man who knows he must speak the truth, even when no one wants to hear it. He knew the report would be unwelcome. The Nazi regime had made it clear through years of increasingly brutal enforcement that pessimistic assessments were considered defeatist, potentially treasonous. Officers had been relieved of command for less. Civilians had been sent to concentration camps for expressing doubts about final victory. But as a scientist, as an engineer trained to follow evidence wherever it led, Becker felt obligated to present the truth as clearly and completely as possible. To do less would be a betrayal of everything he believed about the purpose of science and the obligation of those who possessed technical knowledge. His report was divided into clear sections, organized with the methodical precision of a man accustomed to technical writing. First, the technical analysis of the fuse itself, complete with detailed diagrams, component specifications, and photographs of the disassembled device. Second, an assessment of Germany's ability to replicate the technology, which he concluded was impossible with current resources and manufacturing capabilities. Third, and most dangerous, a strategic assessment of what the fuse's existence revealed about American industrial capacity and what that meant for Germany's prospects of continuing the war successfully. The final section was the most damning, the part that Becker knew would either be ignored or could potentially lead to his arrest. He wrote with careful precision, choosing each word deliberately. The VT proximity fuse represents not merely a tactical advantage, but evidence of fundamental strategic disparity. The ability to mass-produce complex electronic devices during wartime, while simultaneously producing aircraft, tanks, ships, and conventional ammunition in overwhelming quantities, suggests an industrial base of unprecedented scale and sophistication. If American industry can manufacture 40,000 miniature radar sets daily while maintaining or expanding production in all other categories, then Germany's material position is not merely unfavorable, it is mathematically hopeless. No amount of tactical skill, no degree of soldier bravery, no superiority of individual weapons can overcome a production ratio of this magnitude. The arithmetic of attrition is inexorable. He concluded with a recommendation that he knew would be considered treasonous. Germany should seek immediate armistice negotiations before additional casualties are incurred in the pursuit of a war that can no longer be won through military means. Becker's commanding officer, a general who had survived 3 years of the Eastern Front and understood military realities better than most, read the report with an expression that mixed respect and grim resignation. Henrik, you know this will be seen as defeatist, possibly treasonous. They might arrest you for writing this. Should I alter my findings? Becker asked, though he already knew the answer his conscience demanded. No. The report is accurate. The analysis is sound. I'll forward it through appropriate channels. But prepare yourself. The leadership doesn't like uncomfortable truths. They prefer comforting lies. The report was sent to Oberkommando der Wehrmacht, forwarded through the labyrinthine bureaucracy of German military command. Becker never received an official response, but through the informal networks that existed among professional officers and engineers, through the quiet conversations that happened in hallways and over drinks, he heard that his report had been dismissed as excessively pessimistic, the work of an engineer who had been demoralized by enemy propaganda. One general had reportedly said that the American fuse was a trick, a piece of luck, not evidence of systematic superiority. Another officer suggested that German willpower and fighting spirit would overcome any material disadvantage, that the report represented defeatist thinking that could undermine morale. Becker wasn't surprised by the reaction. He had seen this pattern before, had watched it repeat throughout the war with depressing regularity. Intelligence that contradicted Nazi ideology was rejected regardless of evidence. The Nazi regime had built itself on the premise of German technological and racial superiority. Admitting that America had surpassed Germany in industrial and scientific capability would undermine the entire ideological foundation. It was psychologically impossible for the leadership to accept, even when the evidence was overwhelming, even when the consequences of denial were catastrophic. But Becker knew the truth. He had held the evidence in his hands, had measured it with precision instruments, had calculated the implications with mathematical certainty. Germany wasn't losing because of inferior soldiers or flawed tactics. Germany was losing because it was fighting an industrial war against an enemy with overwhelming material advantage. And no amount of willpower, no degree of ideological fervor, no quantity of propaganda could change the mathematics of production ratios and resource availability. Becker's report may have been dismissed by high command, but it reached some field commanders, officers who were dealing with the brutal reality of American firepower every day. One of them, a colonel commanding an artillery regiment that had faced the proximity fuse at Bastogne, requested a meeting with Becker. The colonel traveled to the facility personally, arriving unannounced. his uniform still carrying mud from the front lines, and his face bearing the haunted look of a man who had seen too much death. The colonel sat across from Becker in the sparse office, his hands wrapped around a cup of ersatz coffee that had long since gone cold. "Herr Doctor, I read your report on the American fuse. I need to know if your conclusions are accurate, if what you've assessed is truly the situation we face." "Every word is accurate," Becker replied. "The evidence is unambiguous." The colonel was quiet for a long moment, staring at something beyond the walls, perhaps seeing the snow-covered forests of Belgium, perhaps remembering the faces of men under his command. "My regiment faced this weapon at the Bulge. We lost an entire battalion in minutes. Not hours, minutes. The survivors who made it back told me shells were exploding above them, that there was no shelter, that foxholes offered no protection. At first, I thought they were exaggerating, that the stress of combat had distorted their perceptions. But then I saw it myself, shells exploding in perfect air bursts without any visible observation by the enemy, in weather conditions that should have made accurate ranging impossible." "They weren't exaggerating," Becker said quietly. "The fuse makes every shell intelligent. It eliminates the need for timing calculations, for ranging adjustments, for any of the traditional complexities of artillery fire. Every shell detonates at the optimal altitude automatically." The colonel leaned forward, his voice dropping to barely above a whisper. "Herr Doctor, I've been a soldier for 20 years. I fought in Poland, France, Russia, North Africa, Italy. I've seen every kind of weapon, every innovation warfare has produced. But this changes everything. How do you fight an enemy who can drop explosions on your head with perfect accuracy, regardless of weather or visibility? How do you train soldiers to survive a weapon that makes every defensive position useless? Traditional infantry tactics, everything we've learned over centuries of warfare, suddenly obsolete." Becker didn't have an answer, because there wasn't one. The proximity fuse had fundamentally altered the calculus of ground combat in ways that no tactical adjustment could overcome. The colonel seemed to understand this, his next words carrying the weight of inevitable conclusion. "Then the war is over. Not officially, not yet, but mathematically, strategically, it's finished. We're just waiting for the final act, for the Americans and Russians to meet somewhere in the middle of what used to be Germany." After the colonel left, Becker sat alone in his office for a long time. He thought about all the brilliant German engineers and scientists he knew, about the remarkable weapons Germany had developed during the war. The V-2 rocket, the world's first ballistic missile. The Me-262 jet fighter, the first operational jet aircraft. Advanced tanks like the Tiger and Panther. Sophisticated submarines equipped with snorkels. Technical marvels, all of them. Achievements that would influence warfare for decades to come. But they were marvels produced in small numbers, deployed too late, manufactured in insufficient quantities. Germany had focused on quality and sophistication, while America had mastered quantity and reliability. And in an industrial war, quantity was its own form of quality. The proximity fuse was just one example, but it was representative of a larger truth that German leadership refused to accept. America wasn't just producing more weapons. It was producing better logistics, better training systems, better everything. And doing it all at a scale Germany couldn't comprehend, let alone match. The American military was lavishly supplied with equipment that German soldiers could only dream of. American infantrymen had more radios, more vehicles, more ammunition than German officers. American pilots flew aircraft that were replaced when damaged rather than being desperately patched together from salvaged parts. American ships operated with fuel reserves that would be considered wasteful luxury by German standards. After the war, when production figures were finally declassified and became available to historians and researchers, Becker's estimates proved conservative. He had actually underestimated American industrial capability, had failed to fully grasp just how vast the production system was. The final production total for VT proximity fuses exceeded 22 million units. 22 million miniature radar sets, each one a sophisticated electronic device representing the pinnacle of 1940s technology, all produced in less than 2 years of full-scale manufacturing. To put that number in perspective, Germany's entire production of all types of fuses for all types of munitions during the entire war was roughly 500 million units. But those were simple mechanical or timed fuses, devices that could be manufactured with basic machining and assembly. The Americans had produced 22 million smart fuses while also producing hundreds of millions of conventional fuses for other munitions. The scale of the electronics industry required to support this production was almost incomprehensible. The cost of the VT fuse program exceeded $1 billion in 1940s currency, comparable to the Manhattan Project that produced the atomic bomb. But unlike the atomic bomb, which was used only twice in combat, the proximity fuse was deployed in massive quantities and had a direct, measurable impact on battlefield outcomes throughout the final years of the war. General George Patton, after witnessing the fuse's devastating effects during the Battle of the Bulge, wrote that it won the battle for American forces. He later stated that the proximity fuse was one of the 3 most important developments of the entire war, alongside the atomic bomb and radar. The British, who received large quantities of VT fuses through Lend-Lease, conducted their own careful analysis of effectiveness. Their conclusion was precise and devastating. The proximity fuse increased the effectiveness of anti-aircraft artillery by a factor of 5 and ground artillery by a factor of 3. Every shell equipped with a VT fuse was worth 3 to 5 conventional shells. This force multiplication effect, combined with America's already overwhelming production advantage, created a situation where German forces were simply buried under an avalanche of firepower they couldn't counter or match. Becker survived the war, surrendering to American forces in the chaotic final weeks as Germany collapsed. He was interrogated by American technical intelligence officers who were systematically working through captured German scientists and engineers, compiling reports on what the Germans knew about Allied technology. They were particularly interested in his 1945 report on the VT fuse, which they had found in captured archives marked Defeatist Assessment, No Action Required. Did you really conclude from examining these fuses that Germany had lost the war? An American captain asked during one interrogation session, genuine curiosity in his voice rather than hostility. Becker nodded carefully. Not from the fuses alone, but from what they represented. The ability to mass-produce complex electronics during wartime suggested an industrial capacity we couldn't hope to match. Every component, every specification, required resources and manufacturing capability that Germany lacked. When you can examine a single piece of enemy equipment and extrapolate from it the industrial system that produced it, the strategic conclusions become inescapable. But you were just examining captured ammunition, the American officer pressed. Surely you couldn't determine the entire strategic situation from that. I could and did, Becker replied, with the certainty of a man who had done the mathematics. When you see a single component of your enemy's supply chain, and that component is more sophisticated than your most advanced weapons, and it's being produced in quantities that exceed your total production of similar items, the strategic conclusion is inescapable. You're not fighting a war you can win. You're fighting a war you've already lost, and continued resistance only increases the final casualty count. The American officer made careful notes. We found your report in the German archives. It was marked as defeatist. Did that surprise you? Becker smiled bitterly, years of frustration evident in the expression. No. In the Third Reich, accurate assessment of material disadvantage was considered treason. The ideology required belief in German superiority regardless of evidence. When reality contradicted that belief, reality was dismissed. It was psychologically impossible for the leadership to accept that America had surpassed Germany industrially and scientifically. To accept that truth would mean admitting the entire ideological foundation was false. So you knew your report would be ignored? I knew, but I had to write it anyway. As a scientist, as an engineer, I couldn't remain silent about what I'd discovered, even though no one wanted to hear it. The truth doesn't become less true because it's unwelcome. The story of Henrik Becker and the VT proximity fuse is more than just an interesting technical footnote to World War II. It's a microcosm of Germany's larger strategic failure, a pattern that repeated itself again and again throughout the war. Competent professionals examined evidence, reached accurate conclusions about Germany's deteriorating strategic position, and were systematically ignored or punished for stating uncomfortable truths. Admiral Wilhelm Canaris, head of the Abwehr, Military Intelligence Service, had warned about American industrial capacity before the war even started. His reports were dismissed as alarmist. Albert Speer, Minister of Armaments, knew by September 1942 that Germany couldn't win a production war against the Allies. But instead of seeking political solutions, the Nazi leadership demanded he squeeze every last bit of production from German industry through increasingly brutal methods, including massive expansion of slave labor. Adolf Galland, General of Fighters for the Luftwaffe, recognized American aircraft superiority and warned that the Luftwaffe was being overwhelmed. He was called a defeatist and eventually removed from command. Sepp Dietrich, commanding the Ardennes offensive, knew the operation would fail due to fuel shortages. He was ignored, and the offensive failed exactly as predicted. Now, Becker joined that list of ignored prophets. An engineer who examined captured technology, reached accurate conclusions about strategic reality, and was dismissed because those conclusions contradicted Nazi ideology. The pattern was consistent and fatal. The Nazi regime was built on myths of racial and technological superiority. When confronted with evidence that those myths were false, the evidence was rejected. Maintaining ideological purity was more important than acknowledging strategic reality, even when that denial led to catastrophic consequences. This willful blindness extended even to the proximity fuse's tactical implications. After German forces had been devastated by the weapon at the Bulge, after thousands of soldiers had been killed by airbursts they couldn't defend against, the WWII High Command still refused to acknowledge that this represented a fundamental shift in warfare. Some generals insisted it was just a lucky weapon that German soldiers would adapt to. Others claimed the reports were exaggerated, that battle stress was causing troops to overstate the fuse's effectiveness. The idea that America had developed and deployed a genuinely revolutionary weapon in massive quantities was too threatening to the Nazi worldview to accept. But the soldiers knew. Every German infantryman who survived an American artillery barrage in early 1945 learned to fear the shells that exploded in midair. Foxholes, the basic defensive position that had protected soldiers since World War I, were now death traps. There was no defense, no tactic, no amount of training that could counter the proximity fuse. Defensive positions that should have provided cover from artillery fire were useless. Trenches offered no protection. The fundamental calculus of ground combat had changed, and there was nothing German forces could do to adapt. What haunted Becker in the years after the war, as he rebuilt his life in the shattered remnants of Germany, was how obvious the conclusion should have been to anyone willing to look. The numbers were available through intelligence channels. The evidence was clear. Germany was fighting an industrial war against an enemy with overwhelming material superiority, and no amount of tactical brilliance could overcome that fundamental disparity. The proximity fuse was just one example among countless others. American production statistics told the full story to anyone willing to see it. The United States produced over 300,000 aircraft during the war. Germany produced 94,000. American ship production exceeded that of all other nations combined. American munitions production was so vast that Britain and the Soviet Union were supplied with American equipment even while U.S. forces fought on multiple fronts across the globe. The arithmetic was brutal and inescapable. Germany was outnumbered, outproduced, and increasingly outperformed technologically. The sophisticated weapons Germany did produce, like the Me-262 jet or the type WWII submarine, came too late and in too few numbers to affect the outcome. Meanwhile, America was producing millions of trucks, billions of rounds of ammunition, and yes, 22 million proximity fuses. The scale of production was so vast that waste became acceptable. American forces could afford to expend ammunition at rates that would bankrupt the German war economy. Artillery batteries could fire thousands of shells in support of local attacks that German commanders would consider minor skirmishes. The American military operated with a material abundance that seemed obscene by German standards, casually destroying equipment that German units would have desperately tried to salvage and repair. Becker had seen this disparity, crystallized in those 3 captured shells on his examination table in that frozen warehouse in January 1945. Each one represented a triumph of miniaturization, precision manufacturing, and mass production. Each one proved that America had achieved an industrial sophistication that Germany couldn't match. And there were 22 million more where those came from, with American factories continuing to produce them at 40,000 per day until the war ended. The VT proximity fuse stands as one of World War WWII is most significant yet least publicly known technological achievements. It saved thousands of Allied lives, first by defending ships from air attack in the Pacific, then by devastating German ground forces at critical moments in Europe. General Dwight Eisenhower credited it with making the invasion of Europe possible, suggesting that if Germany had deployed such a weapon 6 months earlier, the invasion might have failed. British Prime Minister Winston Churchill praised it as decisive in defeating the V-1 flying bomb attacks on London. American commanders from Patton to Admiral Arleigh Burke testified to its battlefield effectiveness. But from the German perspective, it was something else entirely. A revelation of just how completely outmatched they were. Not outmatched by a small margin that skill and determination could overcome, but fundamentally, mathematically outmatched by an industrial system operating at a scale they couldn't approach, even in theory. Henrik Becker was one of many German professionals who saw this truth and tried to communicate it through proper channels. Like the others, he was ignored. The Nazi regime's commitment to ideology over evidence, to propaganda over reality, made it psychologically impossible to accept uncomfortable facts, even when those facts were supported by overwhelming evidence. The cost of that denial was catastrophic. The war continued for 4 more months after Becker submitted his report. Hundreds of thousands more died on all sides. Millions more were displaced. German cities were reduced to rubble, all in service of a cause that multiple competent professionals had already concluded was mathematically impossible to achieve. The lesson extends far beyond World War II, speaks to the eternal danger of systems that value ideology over evidence, loyalty over accuracy, comforting myths over uncomfortable truths, when those in power refuse to hear what they don't want to believe. When truth-tellers are dismissed as defeatists or traitors, catastrophic failure becomes inevitable. Becker's examination of those 3 artillery shells should have triggered a fundamental reassessment of Germany's strategic position, should have led to negotiations, to some attempt to end the war before total destruction became inevitable. Instead, it was filed away and forgotten. The smart shells kept falling from the sky. The arithmetic of defeat continued its inexorable calculation, and the Third Reich marched toward its inevitable end, blind to a reality it refused to see. deaf to warnings it wouldn't hear. The proximity fuse changed warfare forever, made air-burst artillery practical and reliable, influenced the development of guided missiles and smart weapons that define modern combat. But its examination by German engineers in that frozen warehouse in Berlin revealed something even more important: the fatal consequences of valuing ideology over truth, of choosing comforting myths over uncomfortable mathematics, of building a system where speaking reality became indistinguishable from treason. In the end, reality doesn't care what you believe. The mathematics of industrial war don't bend to ideology. The smart shells proved that beyond any possibility of doubt.